Hi guys, so in this video we will be solving this problem, pairs of non-coinciding points. Okay, so let's first understand what we have to do in this particular problem. So in this problem we will be given two arrays. One array is X array which represent X coordinates, and one array is Y array. Okay, this represents Y coordinates. Okay, this represents X coordinates and this represents Y coordinates. Okay, and these two coordinates means these two coordinates simultaneously constitutes a point. Okay, so what do I mean by it? Let's suppose the coordinate here is 3, value here is 3 and value here is 4. So we have a point with us which is having coordinates 3 comma 4. Okay, let's suppose the next element here is 2 and next element here is 5. We have another point with coordinate 2 comma 5. Okay, so this array is of length n and this array is also of length n. So what we are having is that we are having coordinates of n points with. Okay, so we are having coordinates of n points with us. Now what we have to do is that we have to tell like how many points are there in this particular n points, which means how many points are there in this uh, n points, like which follow these two conditions. There are two conditions. Those two conditions are what? That 2 points should have what? Same Euclidean distance, and same Manhattan distance. Okay, Manhattan same Manhattan distance. Okay, so we have to consider, means we have to find how many pairs of points are there which are having both of these distances, the value of both of these distances as same. Okay, we have to find how many such pairs of points are there. But before moving on to this point, means further, let's first understand quickly what is Manhattan distance and what is a Euclidean distance. So let's suppose if 2 points are given to us. Okay, so if this is x1 y1 and this is x2 y2, so Euclidean distance is what? Euclidean distance is x2 minus of x1 square plus of y2 minus of y1 square whole under root. This is Euclidean distance. And what is Manhattan distance? Manhattan distance is nothing but y2 minus y1 mod plus x2 minus of x1 mod. This is the Manhattan distance. Okay, so this was about Manhattan distance and Euclidean distance. Now let's get back to our problem. Okay, so what this is what we have to find. Along with that, we have to like not consider, like if a comma b is a pair. Okay, we found 2 points. Let's suppose this is point a and there is another point over here b, which follows these two criteria. That is, for these 2 points the value of Euclidean distance and Manhattan distance is same. Okay, so if we consider a comma b as one pair, then we have to not consider b comma a also. Like b comma a and a comma b, both of them will have same value, but we have to consider either of the pairs, that is either a comma b or b comma a. We have to not to consider both of these. Okay, so either one of them will be considered. Okay, this was one thing. And like another thing was that we have to not to consider the same points, like a with itself. Okay, for this will be what? The Euclidean distance and Manhattan distance both will be 0. So we have to not consider such points, like point b with itself. Let's suppose this point is c, so point c pairing with itself, we have to not consider this also. Okay, so we have to avoid these two. Okay, so now let's move on to the problem part. This was for the solution part. This was for the problem part. Now let's see how we can solve this problem. So we want these two conditions to be satisfied. Okay, we want Manhattan distance should be equal to Euclidean distance. So what is Manhattan distance? Manhattan distance is x2 minus x1 not square, only x2 minus x mod of x2 minus x1. Okay, mod of x2 minus x1 plus mod of y2 minus y1. This should be equal to Euclidean distance. What is Euclidean distance? x2 minus of x1 square plus y2 minus of y1 square whole under root. This is Euclidean distance. So let's square it. Let's square the equation. So what we will get? We will get x2 minus x1 mod whole square plus y2 minus y1 mod whole square plus twice of x2 minus of x1 into y2 minus of y1 mod. Okay, and what will be right hand side? Square of under root is what? Nothing but this, the root will cancel. So what we will get? We will get x2 minus of x1 square plus y2 minus of y1 square. Okay, now we know one property of mod, and that is what? If we square, mod of a square is what? This is simply a square. So what we can write this as? This is nothing but x2 minus of x1 square plus y2 minus of y1 square plus twice of mod of x2 minus of x1 into mod of y2 minus of y1 equals to x2 minus of x1 square plus y2 minus of y1 square. Right, now if you look clearly, like what we can see, this term, this term, this term, and this term, these four are equal, they will cancel out, right? So what we will be left with, we will be left with something like this. We'll be left with twice of x2 minus of x1 into y2 minus of y1 equals to 0. So this is nothing but x2 minus of x1 mod into y2 minus of y1 mod. This should be equal to 0. So if either a, let's suppose this is a, this is b, so either a is 0 or b is 0 or both are 0, in these three conditions we will get a product of 0. So let's suppose if a is 0, then what will be the condition? That is, the condition will be x2 equals to x1. If b is 0, then what will be the condition? y2 equals to y1. Okay, and if third condition, that is a is also 0 and b is also 0, for that what will be the condition? x2 will be equal to x1 and y2 will be equals to y1. Okay, but we don't want this condition. Why we have to avoid this condition? I have told you that we have to not consider a with itself, b with itself, right? So to avoid this condition, we are not going to consider the third point, so we will discard the third point. So for 2 points to have same Euclidean distance and Manhattan distance, either of these conditions, if either x2 will be equals to x1 or y2 will be equals to y1, if this condition is satisfied, then means what, for these two pair of points, the Euclidean distance and Manhattan distance would be same, so we can count these. Okay, so how we are going to, this was for the mathematical part, like we got the mathematical idea, like how we are going to, what we need to solve this particular problem. But now let's see how we can code this problem, like how we'll be able to convert this into code. So what we'll be needing is that, what we will be having some points. Let's suppose x1 y1 is 1 point, x2 y2 is 1 point, x3 y3 is 1 point, and x4 y4 is another point given to us. So what we will be doing is that we can maintain one means we can maintain some unordered map or hash map kind of structure. So what we will be doing is, let's suppose we make a hash map. Let's make, we make a structure. Okay, this is one frequency map. We want, basically we want frequency map. Okay, so we want frequency map, so we will be making three frequency maps with. Okay, so why three frequency maps? Let's suppose what we want is that, for the first time what will happen is that x1 y1, this one is what, frequency map for x, frequency map for x. This one is what, frequency map for y. Okay, and this one is what, frequency map for xy, means x and y both are present. Okay, so what we'll do, we'll one by one scan on these particular characters one by one. Okay, x1 y1. Okay, so first time we got x1 y1. So for Manhattan distance to be same, and for Manhattan distance and Euclidean distance to be same, either of these two conditions should be satisfied. Okay, so what we will do, I will check my x coordinate. What is my x coordinate? My x coordinate is x1. So in frequency map of x, what we will do, what I will do, in front of x1, it is the integer value, how many coordinates are there. Okay, so let's suppose here initially in front of x1, how many coordinates are there? If there are three coordinates, then what will be my answer? I will add my answer to 3. What do I mean by it? It would have been, let's understand what do I mean by it. Let's suppose before x1 comma y1, there is one more point, x1 comma y7. Okay, so what will be stored over here? How many points are there earlier than x1, means what is this particular point, which have same coordinator, this point. So what we are seeing, there is one point x1 comma y7 which is having same coordinates as this one, same x coordinate. So we here one will be stored, so we will have an answer variable with us. So what we will do, what I know that these 2 points have same x coordinates, so what will they will have, they will have same Manhattan distance or and Euclidean distance. So I will increase my counter with what, answer plus equals to 1. I will increase my counter. Let's suppose there was one more element here, x1 comma y8, earlier than this one. So what could have been the possible pairs? This particular x1 comma y1 could pair up with this one, x1 comma y7, and x1 comma y1, this could pair up with this one. This can also pair up with this one. So x1 comma y8 and x1 comma y1, these two can pair up. Since the x coordinates are same, so what will happen, they will have same value for Euclidean distance and Manhattan distance. So what will be present over here in this case? If 2 points are there, so in front of x1 what will be present? 2 will be present. So what I will add to my answer? I will add 2 to my answer. Whatever will be the value stored in front of the frequency map, I will use that value, right? I will store 2 to my answer. So what I'm basically doing is that for each point I will scan. For each point I will check in the frequency map for x how many points are earlier than this point which are having the same value of x coordinate. Whatever will be that, I will add to my answer. Okay, similarly the same task I will do for what? Frequency map of y also. Let's suppose there are, when I am scanning for this particular point, how many points are there? Let's suppose there is a point x3 comma y1 earlier present in the past. So what could happen is that this x3 comma y1 and x1 comma y1, these two can pair up, like because the y coordinates are same, we are having one condition as y coordinates also same. So if y coordinates are same, so what will happen? These two will have same value for this Euclidean distance and Manhattan distance. So here one will be stored in front of y1. So I will, what I will do, I will add 1 to my answer. Okay, so whatever will be the value stored over here, that will be added to my answer. Okay, now this is what the final one is what? Frequency map of xy. Why do I need this? I told you that there was one more condition over here, that was what? If x equals to, sorry, x1 equals to x2 and y1 equals to y2, we have to avoid this condition because we don't want such pairs a comma a, right? So we have to maintain a map for this also. Like if x, this same point was earlier present, like if x1 comma y1, let's suppose we are checking for x1 comma y1. If x1 comma y1, how many points were there earlier also? So if same points are present, so this will be storing, like we can, let's suppose 1 is stored over here. So what will I will do? I will decrement twice into 1 with my answer. Why? Because let's suppose what I did, I paired up x1 comma y1 with itself only, x1 comma y1 with x1 comma y1 only. Okay, so what will happen is that this we have to not to handle, means we have to not count these two as pairs. Okay, let me explain it over here. We have to avoid this case. We have to not pair a comma a, b comma b. We have to avoid such pairs, right? Okay, so what will happen is that in the frequency map, what I will do, when I will pair up x1 comma y1 with x1 comma y1, so what will happen in the frequency map? I will have an answer. In the frequency map, I will see in front of x1 how many points are there. Let's suppose there are now only 2 points. In front of x1, I will see, when I will do the checking for x1 equals to x2, in the frequency map, what I will get? I will get 1. Now I will do the checking for y1 equals to y2. If the y coordinates are same, like these two conditions, we are checking what we were doing over here. So what I will see, like this, for these 2 points, yes, y coordinates are also same. Here also value will be 1. So I will add 2 to my answer. Okay. Finally, what I am seeing, that these 2 points are same. These are of the kind a comma a, and we don't want. So what I will have to subtract? I will have to subtract 2 from my answer. Okay. So that is what I am going to do. Like if this pair exists, means x comma y, that is, if it is a pair of this kind a comma a, then I will simply subtract whatever is the value over here twice into the value which is stored in the hash map. Okay, so this is what we are going to do, solve this problem. So like this was for the explanation part. Now let's move on to the coding part for this problem. Okay, so now let's code this problem. So what do we need to make is that we need some maps as discussed over here. We want some frequency maps for x, y and xy. So let's make a hash map of what? First integer comma integer. Okay, let's name it was map1 equals to new hash map. Okay, and what this will store, this will be what? This will be used for storing x coordinates. Okay, so x coordinates. Similarly, we need another map, same, control C, control V, but this will be used for storing what? Y coordinates, and let's name it as map2. Okay, along with that we need one more map for storing xy. So let's name it was map3. It will be used for storing what? Xy coordinates. Okay, and here it will be not integer, it will be string comma integer. String comma integer. Why string comma integer? Let's see that why do we need string comma integer. If we want something like this, if we want to make a pair of something like this, hash map of integer and something, so we can make a hash map like this. But if we want, what do we want? The our third map was what? Our third map was xy, two coordinates are there, two integers are there. So instead of one integer, what do we want to store? We want something like this: integer comma integer. We want to store over here something like this, along with this one more integer for storing the frequency count. So we will have to write what, if we want to store something like this, then we will have to write our custom hash function. Okay, so that will not be a very good idea. So what we will do instead is that if we want to store something like this, we want x1, we have x1 y1. Okay, so we want to store it like this. So what we can store, we can convert it into string, and we can store a pair of, we can store it like this, string comma integer, and this we can easily do in HashMap. So what we will do, we can convert our this pair into string. We can store it something like this: x1 hash y1 or x1 star y1. Any combination will work. So for here I will simply store them as what, x1 and y1. I will convert them into a string of x1 y1. Okay, and I will use it for storing in my hash map. So that's why I have made the hash map of string. Okay, now what I will do, let's make a variable answer equals to 0. One by one we will iterate. So we will go for integer I equals to 0, I is less than x dot length plus I. So we will get one by one what we will get. We will get the points. Our points will be what, the x coordinate will be stored of our points. The x coordinate will be stored in what, x array, and y coordinates will be stored in the y array. So let's find the x coordinate. X coordinates will be x of I, y coordinate will be y of I. Okay, now let's make the string which we were intended to make. So our string was what, let's make it, name it as s1. X1 will be what, or let's name is what, xy string only. Let's name it as xy. So xy will be what, nothing but x coordinate plus, we can write hash at the rate anything, but I am adding nothing but empty space. So x plus y. Cool. So this is our string. So we got our string also. Now what we have to do, one by one we are getting the points. So for each point what we were doing, if this is our point x1 comma y1, so what we were doing, how many points were earlier which were having the same x coordinates? Because if the points are having the same x coordinates, then this point can pair up with them and they will have same Manhattan distance and same Euclidean distance. So what we will do, let's make one variable integer x frequency. Yeah, x frequency will be what, map1 dot get or default what, x comma 0. Okay, similarly let's get variable y frequency. Y frequency will be what, map2 dot get or default y comma 0. Similarly we want this xy frequency. Xy frequency will be what, map3 dot get or default, what is the string is xy. So xy comma 0. Okay, now what we were doing, like whatever was stored in front of x we were adding, we were having a variable answer. What we were doing, if 2 was stored in front of x, we were adding 2 to our answer. 1 was stored for same y, so we were adding 1 for our answer. And whatever was the value over here, we are subtracting twice for this value, that is twice into 1. And why is twice, I have already explained you, like over here, like we don't want points such as a comma a. So what will happen is that, let's suppose if there was earlier a point something like this 1 comma 2, then again after some time we get the same point 1 comma 2. So for these points, to avoid these points, we don't want a comma a pair. So to avoid these points, we are subtracting twice. And why twice? Because once we are adding for x1 1 comma 2, once we are adding for x1, once we are adding for y, means y coordinate. So we want to subtract both x and y, we are subtracting 2. So 1 plus 1 minus 2 is what, 0 only. So this is cancelling the effect. Okay, this was why we were subtracting with twice. I explained it again, but no problem. So let's move. So what we are doing in our answer, what we will add, whatever the x frequency we got plus answer plus equals to whatever the x frequency we got, okay, plus whatever the y frequency we got, okay, minus a twice into xy frequency. Okay, finally we have to update also, like before encountering, means before we found this particular point, how many such points were there which were having x coordinates as x1, 2 points. Okay, now after this point, now when we find this point, We got one more point which is having x coordinate as what, x1. We will increment this count by what, 1. This will become 3, so that if in future another point comes as x1 as coordinate, so how many points were before which were having coordinates as x1? So here 3 will be stored. Okay, so for this point we have to increment the value of x1 y1 and x1 y1 also. Okay, so let's do that task also. So after this, what we will do in the map1, what we will do, map1 dot put x comma x frequency plus 1. Okay, map2 dot put y comma y frequency plus 1. Okay, here f is capital. Okay, now similarly we want to put the same for map3 also. So map3 dot put whatever is the value over here, like xy comma xy frequency plus 1. Okay, finally what we have to do, we have to return the answer. Okay, so this was for this particular problem. Now let's try to submit this code. Let's see. Okay, answer illegal, start of expression, we did something wrong, we have made a variable answer. Cool. Okay, yeah, answer plus equals to. Now let's try to submit this code, see whether it is working fine or not. Yeah, this is submitting. So this was for this particular question. So I hope you guys would have enjoyed the video.